be going over this example and this example. Okay. So right off the bat, we're going to be assuming that the current in the coil is going in this direction here that I have drawn. So it's going to be going into the page and then out of the page, right? So it's going to be, if you can see it, it's going to be going like that, right? And this tells us that our B field, my thumb, the direction of my thumb is going to tell us the direction of our B field. So in this case, the B field for this one is going to be pointing this way. And then we'll just say that the area vector is going the same way. So the initial flux is going to be, it's going to be big and positive. Not necessarily, but point is that it's decreasing, right? So as this moves further and further away, the distance is going to be bigger. So this is going to get smaller. Small, positive, small minus big. It's going to give me a negative change in flux over change in time. So and then we know that the V induced, the induced voltage, we know that that's opposite of the change in flux over change in time. So we know that that's going to be positive, right? And if we know that the voltage induced is positive, then we know that from the right-hand rule, from the notes, we know that that means that when we do our right-hand rule, we point our thumb in the same direction as our area vector. So in this case, we'll be pointing it to the left. And then when we do this, that's going to tell us the direction of our induced current. So it's going in the same direction as the current I assumed for the coil. So I induced, it's going into the page and it's going out of the page. Okay. Okay, for number 3, same thing. P field's going to the left based on our assumption. Area vector will say it's also going to the left. Initial flux. So this time it's opposite where it's actually getting closer. So at first it's going to start out relatively small, I guess. But the point is that over time it's going to be getting larger and larger as that coil gets closer. So small, positive. And then the final is going to be a big positive. So then the change in flux over change in time. This is going to be big minus small. Wait a minute. I think I screwed up here. At first it's small and it gets bigger. Positive. Right. So then that means that my V induced is negative, right? Because it's going to be a -1 times our change in flux over change in time. Okay, so that tells us that our I induced, right? We're going to be doing that same right-hand rule, but now since our voltage induced is negative, we know that we're going to be pointing opposite of our area vector. So our area vector points to the right. So instead we're going to point, well, actually, no, it points to the left, and instead we're going to point to the right, and we're going like this. So it looks like we're going going out of the page, and then we're going into the page. So it looks like it's the opposite. So it's going to go into the page. No, out of the page, into the page, right?